Hello everyone, welcome to the lab 6 of EC 573 Advanced Embedded Logic Design. In our previous two videos, we discussed about how to use the private timer, and then we discussed about the importance of the watchdog timer and how to use the watchdog timer. Now in this section, we are going to discuss the third timer, which is the TTC. Okay, and that the name of this timer is the triple timer and counter. Okay, so the Zynq TTC, you can see that it indicates that it has the triple timer counter. That means it has the three parallel counters. So you can see that the here so you can see that this is the one timer counter, it is the second one, and this is the third one. Okay, so that's why it is called as a triple timer counter, because each unit has the three set of the counter, and there are two such TTC inside the Zynq SoC, TTC 0 and TTC 1, and in our case we are going to use the TTC 0. Also inside the TTC 0, we are going to use only the first one, but we can use the other one also. It is not a difficult thing. As long as you use the control and status register correctly, you can switch between the timer 0, timer 1 and the timer 2. Now you can see here, this is a more advanced timer with a lot of functionality compared to the previous timer counters we see. So here you can see that this timer has you can see that this timer can generate the multiple interrupts, and also it can generate the waveforms. For example, it can generate the waveform clock cycle with a different frequency as well as duty cycle, which can be used for the motor control or PWM and other applications. So we are going to see that. Also, this timer has again a prescaler is there, so that you can modify this clock frequency, and this prescaler is very popular. It is very powerful. It is quite wider compared to the prescaler in the other one. Also, it has the event timer. So this event timer, what it does, suppose that you have the input signal and you want to find out what is the period of this signal. So you can trigger this event timer on the positive edge, and it will keep on counting until it reaches the negative edge. And by looking at the value of this counter and the corresponding frequency at which it operates, you can be able to find out this period one. So it can trigger based upon the input event, which can be come from the extended mu or the mu. So that is another feature of this timer. Okay, there are many more features. I'll try to explain it as we go into the more detail. So there are two TTC module in the PS in the Zynq SoC. So total there are 6 timer counters. Each TTC contains 3 independent 16-bit prescaler. So it compared to the 8-bit prescaler in the private one, here you have 16-bit prescaler. So your division range is quite large, and 16-bit up-down counters. Your clock can come from the PS as previous counters, or from the PL, or from the external sources. So you have the option those. In our lab, if you see our block diagram, we are using this clock only. But there you can select some other clock as well. It can generate the multiple types of interrupt. Okay, and each TTC can generate the 3 interrupts, one for everyone. So for example, it can generate the interrupt when the timer or counter gets overflow, or it can generate it at the regular interval, like we did in the private counter. At regular time, when it goes to 0, it generates an interrupt, or you can generate the interrupt when the counter matches the particular value. Okay, so you have the additional register. So for example, so your counter is counting from 0 to X. Okay, so then in the private counter, it registers it whenever it reaches the 0, it generates the interrupt. Okay, but in case of this TTC, suppose you have this value Y, so it will generate the interrupt whenever it reaches the 0. Also another interrupt when it reaches the Y. So these are called as a matching register, and there are 3 matching registers are available. So you can generate the multiple or periodic, means at any time you can generate the interrupt as per your requirement. Also, it can generate the waveform like PWM waveform. pulse width modulation waveform through the MIMO, through the MIO or the to the PL. Okay, we are going to see that. Okay, so each prescaler module can be independently programmed. So you can see that each prescaler here for every timer counter, this can be independently programmed to use the to divide the input clock pulse as per the requirement. The selected clock is from 2 to 65536 because it's a 16-bit corresponding prescaler. The counter module can count up and down, so there is a flexibility is there, and it can be configured to count the given interval. So you can see that if there is a pulse on this one, if you want to count this one, that is also event one, but this counter, it can count from say 0 to X, or from X to 0, or from X to Y. So any interval also you can make it count. Okay. Then it also compares that there are 3 matching register as I discussed before. It can compare those value of the current value of the counter to those value in the matching register and generate the interrupt whenever there is a match. Okay, so in addition to the generating the interrupt at the extreme end or when it passes through the 0, it also generates the interrupt when the value of the timer matches with that corresponding value in the matching register. So the interrupt types is the counter interval. Whenever it reaches the particular value, it will generate the, for example, when it goes to 0, it will generate the interrupt. When it matches the particular value in the matching register, it will generate the interrupt. When the overflow happens, like it will, suppose that you have the 4-bit counter. Okay, so this counter can count from 0 to 50 and back to 0. So that means when it reaches the 5 overflow has happened, it goes to 0, it will generate the interrupt. But you may design the counter to count from 0 to say 4 and then back to 0. So this is nothing but the counter interval where it goes to up to 4 and back to 0. Whenever it reaches the 0, it will generate the interrupt. And suppose you have the match interval 2, so that means it will generate the interrupt whenever it reaches the 0 as well as when it reaches the 2 value. So that is called as the match interrupt. And then also it will generate the interrupt when the event timer overflow. For example, as I told you that this timer can use to calculate the pulse width. Okay, so by using the register, you will know the what is the value of the counter. But sometimes it may happen that if the counter is not sufficient, in between here your counter will overflow, and then your pulse width calculation may go wrong. So by knowing the status of this event timer overflow interrupt, you will know that during this particular event, the timer overflow interrupt has happened. So whatever the event timer is giving, it may not be a correct value. So that event timer overflow will be useful. Okay, and each type of interrupt can be individually enabled. So there are modes of operation of the timer. One is the interval mode. So in this one, counter increments or decrements continuously between 0 and the value of the interval register, that is the X value which you can set. Also, you can determine the direction of the counter by using the appropriate bit in the control register of the timer. Interval interrupt is generated when the counter passes through the 0. And also, in addition to the interval interrupt, you can generate the matching interrupt whenever the counter value is equal to the corresponding value in the matching register. Okay. Similar to the interval one, there is an overflow mode. So overflow mode means X is set to the maximum value. Okay. So in this case, for example, if it is a 16-bit counter, X is set to the 0xFF. So whenever the counter reaches the, when counter goes through the 0, it will generate the corresponding interrupt. Okay. So whenever the counter passes through the 0, it will generate the overflow interrupt, and then similarly, it will generate a matching interrupt also. Okay. So that is what the event timer, the TTC timer is. Now in the TTC timer, as I told you, it is a timer counter, and there is also event timer, which I want to focus slightly more. This will be used to find out the duration of the particular event. For example, find out the clock pulse, duration of the clock pulse, or the frequency of the input pulse. So the event timer outputs by having the interval invisible 16-bit counter clock at the CPU 1x frequency. which reset to 0 during the non-counting phase of the external pulse. For example, you have configured this counter to count the to start counting when this pulse, external pulse, becomes 1. So when the external pulse is 0, this will be reset to 0. And as soon as this external pulse becomes 1, it will start incrementing during the counting phase of the external pulse. So this event register is updated with the non-zero value of the internal counter at the end of this counting phase. So whenever you reaches the end of the counting phase, the counter value is copied inside that event register, which we can read, and then we can use that to count to find out the clock of the period of the corresponding pulse. So this value of the counter is copied into the event register after the end of the counting phase of the external pulse. Therefore, it shows the width of the external pulse measured in the number of cycles of this particular clock frequency. But we need to make sure that we take a special case when the overflow happens. For example, suppose that the total number of clock pulses required are 24, but you use only the 4-bit counter. So what we'll get is that after you go to the 24-bit counter, it will become 0 somewhere, and at the end you will get only the value, say 8. And then you will find out the clock pulse as per this value 8, which is wrong, right? So in that case, you will also have to check whether there was a event overflow interrupt has been generated. If it has been generated, that means you should you should be aware that this value 8 which you have received in the event register is not correct, and that's why then you need to relook at your counter setup while setting up the number of bits in the counter so that you can measure the pulse accurately. So similar to any other register, you have the corresponding register. For example, you will have the control register for the clock to decide what is the source of the clock, what is the prescaler of the clock, and you will have a control register for the counter, like to enable the counter, mode of operation, up and down, enable the matching, waveform output, disable, enable it, all those you can do it. And then you will know the current status of the value of the counter by using this register. You can get the current status of the counter. In addition, you will have the interval register to set up the interval value. For example, if you want to count from 0 to x, you need to set up the corresponding value in the interval register. We are going to use this in our lab. Similarly, you can set the matching value. If you want to generate the interrupt at the in between, you can set this matching value. Then you will have the corresponding for interrupt, enabling, disabling status, setting up the interrupt, clearing the interrupt. You have the corresponding interrupt register. And when you want to use this as a event timer, you have the corresponding control and the status register. Okay, so we need to understand how we are going to use it. We are not going to use all the features of the TTS. We are going to use few features. What we are going to do is that we are going to use this timer to generate the waveform of a particular frequency and the particular duty cycle. Okay, so generate a PWM waveform of the desired duty cycle as well as frequency using the TTS, and we are going to see that waveform using the ILA. So again, we need to configure the TTC timer same as the other timer and set up the PWM generated mode, so that we need to inform the timer that you should generate the waveform. We need to do the setting, we need to calculate the interval, we need to calculate the matching value. Okay, so for the desired output frequency, calculate the timing parameters, configure the timer with the parameters we have calculated here, then set up the interrupt, include the ISR which clears the interrupt. Okay, start the timer, and you can check verify the waveform on the ILA. Okay, and you can then check it for the different duty cycle. Okay, so this is the TTC theory behind the TTC. Now we will go back to our application code and we'll see how this timer can be used in the real application. Okay, so now this is our watchdog timer. We have already discussed about the watchdog timer as well as the private timer. Now we will go to the third part of the lab, which is the TTC timer. And let's quickly go through the corresponding C code. Again, in the C code, first look at the header file. Like here, I need a corresponding .h file. I'm not going to use the SU timer, so I don't need a corresponding .h file. I'm not going to use the watchdog timer, so I don't need a corresponding .h file, but I'll need a .h file of the TTC timer. Okay, I'll encourage you to look at this .h file, understand the different function inside the .h file. Then what I'm going to do is that we'll start with the main code. Okay, first thing is that now I need to find out a lot of parameters for the timer. For example, I need to for the output frequency clock I want to generate, I need to decide what frequency I want. Now for that frequency clock, what is the duty cycle on I want? These are my inputs, so I'll decide those one, and based upon those inputs one, I need to find out the timer parameters, like what should be the interval value, what should be the matching, because you can see that the after based upon the duty cycle, when the timer reaches the duty cycle, I'll toggle the value of that my waveform so that I get a clock with a particular duty cycle. So I'll find out that match value, I'll find out that interval one, I'll find out the prescaler one, because I need to set the prescaler to get any frequency I want. And then I need to set up the options in the timer, because I need to set up, I may not be using all the options. For example, I'm not using the event timer option today, so I need to disable that. I need to enable the waveform output. Then I need to enable the polarity of the waveform, so I can toggle between the different polarity. So that options I need to set. So I'm just setting, I'm just initially I'm just defining those variable, and those variable what are the types are also already given in the X parameter, the corresponding the header file of that corresponding timer, which is the xttcps.h. So I'll encourage you to find out the corresponding the data type of the each value. So how to do that? So let's go to the TTC ps.h, and suppose we want to go to the prescaler. Now if you go to the prescaler function, let's go to the prescaler function which sets the prescaler value. Yeah, so you can see that this is the prescaler value, and you can see that the prescaler value is U8. Okay, so here here I can see that the prescaler I have defined it as a U8. Similarly, there will be interval function. You need to define the corresponding value of the interval. Okay, so you should take care of these things. Then similar to any other timer, I'll first do the timer initialization, that I have done it. Then now I need to define the timer options. Okay, again I'll go to the ttcps.h. Again in that .h file, if you see here in the .h file, you will see that in the beginning they have given what are the options you can set. Okay, so these are the different options are there. For example, if you want an external clock, you can inform that, but we are not using it, so we don't need it. Whether you want to add the negative clock edge, you can do that if you want it, but we are not doing it. Then whether you want to increment or decrement, you can do that. Whether you want interval mode to be enabled, because we want an interval mode because we are going to load the timer with the particular X value. Then whether you want a match mode, we want to have the match mode because we want to generate the intermediate interrupt. And then if you want to disable the waveform output, you can do that, but we want to see the waveform output, so we need to enable it. And then the waveform polarity you can toggle bit by using this flag. Okay, so you can see that I'm enabling the interval mode, I'm enabling the match mode, and I'm enabling the waveform polarity. I'll encourage you, after you complete the lab, you can remove this option, waveform polarity, and see the effect on the output waveform you get. Then I use these options by using the set option functions. I'm setting the timer. Okay, now for this timer frequency, I need to find out the prescaler and interval values. Okay, so by using this inbuilt function, I'm passing the frequency which I require, and from that I'll get the interval and the prescaler value. Then I'll set those prescaler value inside my timer. Now for the duty cycle, I want to find the corresponding match value. So for example, my timer is going to count from 0 to say this interval. Then the duty cycle, for that duty cycle, it should remain the 1. So I'll calculate the count, up to what count it should remain the 1, and after that it will toggle it. I'll calculate that match value, I'll set the match value. Okay, like we did in the previous two cases, we will set up the interrupt and we'll start the timer, and that's it. Okay, in the interrupt setup, the process is same. We have the 6-step process which we are doing till now. And in the timer ISR, what I'm doing it here, I'm finding out the interrupt status, and I'm going to receive two types of interrupt, right? One is from the, I'm going to receive two types of interrupt from a single interrupt source. For example, from the TTC timer, it will generate the interrupt in the two scenario, when your timer reaches the match value and when it reaches the corresponding interrupt, that is the maximum value. So I'll just print it. When it reaches the, it will generate the, it reaches the interval value, and when it reaches the match value, and you will see that it will happen it alternatively in our case. Okay, so this is the code. Now what we are going to do is that we are going to test this on our hardware, and then we'll see the waveform on the ILA. Okay, so now I'll program the remote board. I'm going to use my ttc.elf file. In the JTAG terminal, now you will see that alternatively will move between the interval and the match interrupt. So you can see that we are getting the interval interrupt, then match, then interval, then match, and so on. Okay, and the corresponding waveform will go to the vivado. Okay, so let's look into the vivado ILA outputs. Okay, so what we will do is that since the code is running in the background, we'll just look at the corresponding waveform output directly. In case you are not able to see any waveform here, you can just click on the add probes, and I'll just check the TTC output one, and I'll just run the trigger so that I get the output here. So you can see that we are getting the output waveform with the 90% duty cycle. Okay, so you can see here I'm getting the output waveform with the 90% duty cycle. Now let's change the duty cycle. What we will do is that we'll stop the code. Then I'll change the duty cycle to say 30%. And then we'll run the code again. So after this, now you will see in the in case of the vivado, we will get the another new updated waveform with the 30% duty cycle. Okay, so we are not getting anything. So let's look at what is the issue. Okay, so we had not ran the code, so that's the reason. So you can see that now I'm getting around with the 30% duty cycle. Okay, so this is the one. Now what we can do is that we can change the polarity of the code. So let's look at this one. So now I'm just going back to the default polarity, and now you will see what happens. Okay, so this is the polarity. Now let's run the code again. Okay, so go to the vivado and then just take the existing samples. So now you can see that the polarity has been reversed. So this is how you can check the polarity. Okay, so you can play play with these things, and you will be able to get the different types of waveform as per your requirement.